Hello friends, welcome you all again BSc Electronic Science class. Myself GG Patil, Department of Electronic Science, KTHM College, Nasik. In this video lecture, we shall study the state assignment techniques and the algorithmic state machines, generally called as ASM. So let us start. First, state assignment techniques. The importance of state assignment in state reduction of sequential circuit. The If the proper states are assigned to the state machines, then the number of states can be minimized. That can be seen with the example taken in the next slide. First, the definition of state assignment. The assignment of unique binary codes to the state variables of a sequential circuit is called state assignment. In the state assignment, we assign a unique binary code to the various states present in the state machine, and this process of assigning the unique binary code is called the state assignment. There are number of advantages of state assignment can be observed in the state sequential machines. Some of the advantages are listed here. With proper state assignment, the number of terms in the final excitation equation get reduced. Then it impacts final realization cost. That is the second advantage of the state assignment. And the third one listed here is the circuit complexity reduces with a proper state assignment. So these are the advantages of a state assignment, in which uh, the number of terms in the final excitation equation get reduced. Since the number of terms get reduced, the number of components required for implementation of that sequential circuit get reduced. Since the number of components get reduced, the circuit complexity get reduces with the proper state assignment, and the since the number of components are less, the speed of the circuit get enhanced with a proper state assignment. So these are the advantages of state assignment. So in simplifying the sequential machine, in reducing the number of states in the sequential machine, the state assignment has an important role. It must be assigned properly. So let us study the more systematic technique to assign the binary codes to the states. Here one example of state assignment is taken. Here in the state table, one state machine is described, and in that state machine, as we see, there are four states A, B, C and D, while the next states and output are listed in these two columns. Here x equals to 0 is one input and x equals to 1 is another input condition, while these are the next states and outputs, they are given here. So how the state assignment matters in the final realization of the state machine, that can be observed in this example. Now see, there are two state assignment methods are used for this state machine. See here, the state assignment 1 and state assignment 2. The states are assigned in two different ways, and the next state columns are given here for x equals to 0 and x equals to 1, as it is given in the original state table. The state assigned are shown by these two variables f2 and f1. Since there are four states we have assigned, a 2-bit binary code for each state. So the states assigned in the first state assignment are: A has assigned a 0 0, that is F2 F1 is 0 0. B has assigned a code 0 1. C has assigned a code 1 0, and D has assigned a code 1 1 in state assignment 1. So wherever A is present, instead we will write the 0 0. For B we shall use 0 1. For C we will use 1 0, and for D we will use 1 1. So with these states assigned, the next state columns can be written with modified state like this. They are given here. See, in the first original table, with present state A and x is equals to 0. Next state is A and output is 0. And for A, the next state assigned is 0 0. So next state is 0 0 and output is 0. And under x equals to 1 input condition, B is the next state and output is 0. So since B has assigned a 0 1, 0 1 is the output and next state output 0 1 is the next state and 0 is the output. Similarly, for state B, when x is equals to 0, next state is A and output is 0, and since A has value assigned 0 0, so it is 0 0 and output is 0, while for x equals to 1 condition, next state is C and output is 0, and since C has value 1 0, so next 1 0 and output is 0. When present state is C, under x equals to 0, next state is D and output is 0, and since D has value 1 1, so the next state is 1 1 and output is 0, and under x is equals to 1, next state is B having value 0 1 and output is 0. And for state D, the A is the next state when x is equals to 0 and output is 1, and A has value assigned 0 0 and output is 1, and for x is equals to 1, the next state is B for present state D and output is 0. So B has value 0 1 and output is 0. So in this way, with this state assignment, we can rewrite the present state table of a given state machine. This is a state assignment 1. By another method, that is a state assignment 2, the states are assigned, a unique binary codes are assigned to the states given here. A has assigned 0 0, B has assigned 0 1, C has assigned 1 1, and D has assigned 1 0. So C and D, their states are get changed. Here C has 1 0, while here C has 1 1, and in this case D has 1 1, while here D has 1 0. So with this change in the state assignment, again rewrite the next state and output values. So here for present state A, next state is A and output is 0, and A has 0 0, so 0 0 and 0. For x equals to 1, next state is B and output is 0, and B has value 0 1 and 0. For present state B, next state is A and output is 0, and next state is A having value 0 0, output is 0. And here next state is C and output is 0, and here C has value 1 1, not 1 0, so 1 1 and 0. When present state is C, the next state is D and output is 0, and D has value 1 0, so 1 0 is written here and output is 0. And when x is equals to 1, C has a next state value B, and B is assigned a code 0 1 and output is 0. And the lastly column for present state D, the next state is A having value 0 0 and output is 1, and next state is B having value 0 1 and output is 0. So in this way the given present state table is assigned values. The states are assigned a value with two different ways, by state assignment 1 and state assignment 2. Now here we have to see how the state assignment matters in the final realization of sequential machine, or final expression or equation of the sequential machine. So we'll derive the equations for state assignment 1 and state assignment 2. So here the first one, the state assignment 1. If we observe the output for D2 in state assignment 1, observe the output column D2 in both of these input conditions, that is x is equals to 1 and x is equals to 0 and x is equals to 1. So here D2 is 1 is here, and in this case for x is equals to 1, D2, that is output is 1 for D2 is here. So only two cases are there where D2 output is 1. So we'll write the equation for that D2. So how to write the equation? Here D2 is equals to, what are the input conditions? See the F2 is 1, so will be taken as F2, and where 0 is present we'll take it as a bar or dash. So in this case the input conditions are to be taken like this: F2 F1 dash, and since x is 0 we'll take 0 as dash x dash. So it becomes F2 F1 dash x dash, or x is equals to 0, plus here again the D2 is 1 for x is equals to 1 condition. We'll write the inputs F2 dash, since F2 is 0, F2 dash F1 x, F2 dash F1 x. So this is the expression for D2, output D2, and similarly we'll write the expression for D1 under x is equals to 0 and x is equals to 1. So here D1 can be observed here. Here it is 1, and it can be written as F2 F1 dash x dash, F2 F1 dash x dash, plus here after simplification the equation is written by using the Boolean identities or simplification. Then this equation is derived. The actual equation is for D1 or state assignment 1, F2 F1 dash x dash, plus here output is 1, so this condition is written as F2 dash F1 dash x plus F2 F1 dash x. Why F2? F2 is 1, x, F1 is 0, so F1 dash, and x is 1, so it is taken as F2 F1 dash x plus F2 F1 x. And after solving, after simplifying, the equation becomes D1 equals to F2 F1 dash plus F2 x plus F1 dash x after simplification. So these are the equations for state assignment 1. Now for state assignment 2, the excitation equations are derived in this way. See here again same, for we have to derive equation for D2 and D1. So for state assignment 2, under x is equals to 0, observe the D2 column, output is 1 here. For that output D2 equals to 1, check the input condition. Inputs are F1 1, so we'll take F2 F1 x dash. So here the term is F2 F1 x dash for this one, and plus here only one condition where D2 is 1, and for that condition the inputs to be written F2 is 0, so F2 dash F1 X, F2 dash F1 X. So that is the equation for D2, and for D1 in state assignment 2 the equation can be derived. How? Let us see. Here all D1 are 0, so no need to take any term, and for X is equals to 1 all D1 outputs are 1, so we can take D1 equals to X. Since for X is equals to 1 all outputs are 1, so we can write in this way D1 equals to X. So these are the equations, excitation equations for state assignment 1 and state assignment 2. Now if we observe these two equations, the same state table, just differently assign the state. In case first and case second, the final equations which we get, they are different, and if we see it carefully we come to know that in state assignment 1 the number of terms obtained for D2 and D1, they are more, contains three variables in each term and containing much number of terms, so it is a the equations derived in state assignment 1 are complex, while in case assignment state assignment 2 D2 has two terms in the final equation while D1 is equals to X. So using state assignment 2 we have got a less simplified equations containing less number of terms. Since there are less number of terms, the number of components required to implement the circuit are less. Since the number of components are less, the complexity is reduced and the speed of the circuit get enhanced. So where F2 and F1 are state variables and D2 and D1 are excitation variables, equation using assignment 2 requires less number of gates than the state assignment 1. That is very clear from state assignment 2. So that is the advantage of assigning the proper state in sequential state machine, so that the number of terms can be reduced, circuit complexity can be reduced, circuit speed can be enhanced, and the cost of the circuit is get reduced. These are the advantages of state assignment in sequential state machine. Okay, next, the state assignment techniques. The state as in this slide we have to see the state assignment permutations formula. If in a sequential circuit containing n number of states realized by m state variables, then the number of possible state assignments S is given by the formula S is equals to 2 raised to m factorial upon 2 raised to m minus n factorial, where S is the number of possible state assignments, m is the number of state variables, and n is the number of states. Such examples are asked in examination, so we should able to find the number of possible state assignment. If a state machine has 4 states with 2 state variables, then the number of possible state assignment can be calculated as 2 raised to 2 factorial upon 2 raised to m minus n factorial. Put the values of m and n. M is 2 and n is 4, so 4 minus 4, that becomes 1. 0 factorial is always 1, so 4 factorial by 1 is equals to 24. Student can take their own values of m and n and can find the number of possible state assignments. Now then, Next is the algorithmic state machine. As we know, an algorithm it is the systematic description of a process or operation. For example, any complex process like industrial control problem can be described in algorithmic form. We have also studied the algorithm in the programming language like C programming, uh, or in a microcontroller programming language also we use the algorithm. It is nothing but a systematic description of a process or the operation of the particular sequence, and these algorithmic state machines are used to describe the sequential state machine in digital system designing. The flowcharts used by computer programmers to express algorithm that we know. The ASM charts use flowchart symbols from computer programmer to express operations of the sequential circuits. The symbols used in ASM are same as that of the computer programmer. It appears like a programmer's flowchart, and this is important. The ASM chart gives the hardware solution to logic designer. It gives the hardware solution to logic designer. That is important. Okay. The ASM chart shows the graphical representation of a functional and hierarchical relation that exist between different operations carried out by elements of a system. Contains different symbols represent different operations. The lines and arrows indicate relationship exist between these operations. Basically, three symbols are used in the ASM. They are given here. The three primary symbols used in ASM are a state symbol, input condition symbol, and a conditional output symbol. We'll see these three symbols one by one. The first is ASM state symbol. In that, uh, the symbol is shown here. At the entry side, the state name is given and assigned code to the state is to be written. The outputs of the state are to be listed inside that square, and the state exit are to be shown at the output of the state symbol. This is input side and this is output side. The outputs to be listed inside, and these are the unconditional outputs. This is a state symbol. Then the decision symbol, ASM decision symbols. Here a diamond and modified diamond. It is shown by two ways. Decision symbol, it is for decision symbol a diamond is used. This is the entry to that condition, and inside the diamond that condition is to be evaluated, and after the evaluation if it is false, this path you will be followed, and if it is true, it is followed by this path. Inside the diamond the decision criteria is to be written. See here one example is taken. Entry, and this expression is given a or b bar. That is a NOR logic gate expression is there. If it is 0, follow this path. If it is 1, follow this path. So this is the ASM decision symbol. And the last one is ASM conditional output symbol is there. The symbol is shown here. The entry, exit, and inside the output variables are to be listed. So these are the three symbols used in the ASM chart. The state condition symbol, input state symbol, ASM state symbol, this one, then the ASM decision symbol, and ASM conditional output symbol. So in this way, in this video lecture, we have studied the state assignment techniques, its advantages, how it matters in the final realization of sequential state machine, Then in the latter part, we have studied the ASM, the algorithm, the different symbols of ASM. So with this, we conclude. Thank you very much. Thanks.